section 1.3 is titled the Cartesian coordinate system. So we're going to be doing quite a bit with XY ordered pairs, with graphs in this section. So let's actually start by, and I don't have a good space where it here was, this is what I want in your first spot. The ability for you to draw in and remember the details on a Cartesian coordinate system. So first of all, this is your x-axis, and this one is your y-axis. You'll remember that the positive on the x-axis is on the right, the negative's on the left, just like a number line. And on the y-axis, the positive is on top and the negative's on bottom. And in addition, if we isolate a location, say like this, that we always write our ordered pair, this is the x1, we'll say x1 value, and this is the y1 value, as x1 first, as the x value first, and the y value second. Now on the first exam, when we did that problem solving section, I put a whole bunch of formulas on your exam. So I'll let you know right now that the formulas that are showing up as we continue on, unless I tell you otherwise, you're expected to memorize them. Most of them are ones you've memorized somewhere along the way in the past. It may have been a while, and I understand that, but a couple of them are here actually on this slide, the distance formula and the midpoint formula. So distance formula measures the distance between 2 points, and it's measured as follows. It's the square root, and we subtract the two x values, and we square it, added to the difference in the two y values, squared. So a few things that people often have memory lapses when they try to recall this one is they might forget to do the squaring inside. So you can kind of take in mind the fact that the squaring and the square root processes are inverses. You cannot just cancel a square root with a squares, otherwise I would give you the formula that way, right? You can't do that. That's much like the one on the test where I said the 3 minus I squared does not become 3 squared minus I squared. It's the same thing. Or you might forget that there's a subtraction or a positive sign in those locations. So this is always the difference here in each of these, and then it's the sum in between. This has direct correlation to Pythagorean theorem if you think about it from the perspective of a triangle. And let me just show you that in case it might help you to remember what's actually happening on the equation. So if we found the distance between these 2 points, and we're trying to connect them to find the distance would be the length of the line segment connecting them. What we actually are doing is we're creating a triangle in here. So if this is x1 and x2, the distance between these is showing up here, and it's squared. And over here is the y1 and the y2, and the difference between these is showing up here squared, which looks an awful lot like each of the sides of the triangles being squared, like in the Pythagorean theorem, a squared plus b squared equals c squared, and there's your c squared for your diagonal. So that's actually where it's coming from, that correlation. And we'll see another correlation here toward the end of class for the Pythagorean theorem as well. The midpoint formula is actually exactly what you do when you average things. So what you're finding with the midpoint formula is the two x values added together and divided by 2. So think about like what you do when you like average test scores or average homework scores, right? You add them together and divide by how many you have. And then the same thing for the y values. You're adding them together and dividing by 2. So it's just an average location. That's what the midpoint formula is. So our first couple of examples are going to be finding distance and midpoints. And for the sake of what we're going to be doing here in a moment, you might want to grab a calculator out if you have one with you. If you don't, it's not a big deal. But we are going to find some approximations. Sometimes questions will ask you to approximate something and not leave it in square root form. It just depends on the problem. So I want to make sure that we're getting the same thing as we're working through those problems together. So like I said, on number 1, we're going to find the distance and we're going to find the midpoint. And they give us 2 points. And these are whole values, right, like integer values. I don't get any decimals or fractions. I'll do one with decimals here in a moment. We need to be careful about signs. That's usually the thing that trips us up, is adding or subtracting and forgetting something about a negative in there, and it throws things off, that kind of stuff. But we'll find the distance first. I didn't mention it over here, but it might be worth mentioning that there's absolutely nothing special about the order of the subtraction here. Because since you're squaring things, subtraction just changes the sign, right? Like 5 minus 2 is the same as 2 minus 5. At least it is when you square it, because the sign takes away the square takes away the sign, any of the negatives that you have. So the order of the subtractions don't make any difference at all. Just for the sake of us putting them in the same spots, I'm going to identify the first one as x1, y1, and the second one as x2, y2. Again, not because it matters, but just so that you can see where the values come from specifically. So I need the first x value, which is negative 3. And then it's minus the second x value, which is 9 squared. And then to that, I will add the first y value, which is negative 2, minus the second y value, which is a positive 3, and square it. So if I had written these in here reversed, it'd be okay, right? It wouldn't make any difference. What is negative 3 minus 9? Yeah, it's negative 12. So I have negative 12 squared. And what is negative 2 minus 3? Negative 5 squared. So what is negative 12 squared? 144. And negative 5 squared? 25. Do you know what 144 and 25 are added? Yeah, it's 169. And that's actually a really nice one that we don't even have to approximate to write down a value for. The square root of 169 is 13. So that one works out really nicely. Now, the midpoint formula takes the two x values and it adds them. So I have negative 3 plus 9 instead of minus 9 divided by 2. And I have negative 2 plus 3 divided by 2. So negative 3 plus 9 is 6, and 6 divided by 2 would be 3. Negative 2 plus 3 is 1, and 1 divided by 2 can be written either in fractional form or you can write it in decimal form if you prefer as 0.5. So we found the distance and we found the midpoint. And this was an example of one that works out really clean. It's really very nice looking values at the end. So we'll do one now that doesn't have so nice of values here at the end. Should be no surprise since you're looking at the problem. And you see, decimals to start with, right? So we're finding the exact same two values, right? The distance and the midpoint. So we're taking, again, I'll label them x1, y1, and x2, y2. And you can put them in that order. So x1 is negative 2.3 minus x2 is, sorry, that x doesn't look very good. Let's fix that. x2 is 4.7. So minus 4.7 squared. Probably going to want your calculator to do that in a minute. The other one is y1 is 1.5. So plus 1.5 minus, and it's minus a negative 7.5, right? So we need to be careful because this one will end up being addition right here. Agreed? Minus a negative? Yeah. So be careful to notice your signs changing on that one because of the way that it worked out. So grab your calculator. If you do negative 2.3 minus 4.7, this is actually, and I'll write down an intermediate step, although you could just jump to the next one if you'd like. This is negative 7 squared. And then the 1.5 plus 7.5 would actually be 9. It's 9 squared. Okay, so negative 7 squared is 49. 9 squared is 81. So it would be perfectly fine if you just skip to that step where I wrote the negative 7 squared and the 9 squared and you jump to here. You got to show me some steps in between, but you don't have to show every single one of them, all right? 49 and 81, what do those add to being? What is it?
130.
130. Okay, so we have 130. We could break that down, or we could attempt to, right, depending on the directions. So let me just say, if the directions say to keep it in exact form, we would factor and see if this factors. So I have 10 times 13, but 10 is 2 times 5, right? There are no numbers showing up twice. So if it wants the exact answer, I'm actually done right here. Agreed? If it wants a decimal approximation, you can take the square root in your calculator, square root of 130, and we can get that it is approximately 11 point, we'll put 2 decimals for 0. And again, it would tell you. It'll tell you in the problem. I'll tell you in the problem too if I ask it on a test or a quiz. I'll tell you round to this, or I'll tell you keep it exact. So it should not be a question of like, what does she really want? I'll tell you. Yeah, so this one would approximate to 11.40 or something like that if we were asked to approximate to 2 decimals, for example. All right, so let's do midpoint formula.
And you said it will specify whether it wants it in the radical or in the...
Yes, if it doesn't say which one, it's expecting you to leave it exact, right? That's the default. So if it doesn't tell you to round, you're going to do it exact. In this case, it'd be square root 130, or if it factored and simplified, you would do that part of it. So if it wants you to round, it'll tell you to round it. Yeah. All right, so midpoint, we're going to be adding the values together. So I've got negative 2.3 plus 4.7 over 2, and 1.5 plus a negative 7.5. So this time they will actually end up being subtracted because it's plus a negative. Divide by 2. So if I take negative 2.3 plus 4.7, just so that I have an in-between step, not because you have to, but just so you have it, I have 2.4 divided by 2. And on the other one, when I do 1.5 minus 7.5, I have negative 6 divided by 2. So again, you don't have to show that step, but if it helps you, then by all means do so. Otherwise, you get 1.2 common negative 3. And please be careful as you're doing that your decimals and your commas do distinctively look different. I have a child in my home that constantly makes us guess what he wrote down on everything. So be careful about that. All right, any questions about distance or midpoint? Okay. This is actually the other location where there's a connection back to the Pythagorean theorem. And you might seem like you're not, but let me just show you when we get there. It's talking about the standard form of a circle. So we're talking about a circle with center HK and radius R. So if you think about where it's being drawn or how it's being drawn, there's a point here. That point's the center, and there's a circle around it. So the way that this is being described, this is R, right? That's the distance here. And then the location for the center is the point HK. So that's the visual that it's describing. The equation that comes about for that is x minus h squared plus y minus k squared equals r squared. And the Pythagorean theorem that's showing up, or that I keep sort of alluding to, comes from the fact that, let me change it to, we'll use green, that there is an inherent triangle showing up here. Let me show it, actually let me do it this way. So if you're looking at this is not a good picture for showing this. Let me shift it up a little bit so that I'm not hitting an axis. So if you're looking at the distance, hang on, that'll be easier. If you're looking at that distance right there in yellow, that's the R. Ooh, and now I'm running into my yellow over there. The distance here that's R, you can actually take a triangle like this, and that is the distance that's measuring the change between these values. So you can see the inherent sort of triangle showing up inside of the circle. Also, if you think about this equation compared with this equation, this has a piece where it's being subtracted and then squared, just like x minus h squared. This one has a piece just like the y minus k being squared. They're added together, and while you don't see a square root, what you do see instead is the other side being squared. So if I were to square both of these sides, I'd have d squared here, just like I have r squared on the other problem, and no square root on this side. They're actually the same formula, just utilizing different features. So on number 3, what we're asked to do is to simply write the equation, okay? So we do have to be a little bit careful again with negatives, just for the exact same reason that we've had to do so on the distance formula and the midpoint formula. So my x and my y are grouped with this h and this k. And then my radius right here is the 1/3. So I have x minus, and it's minus a negative 1. So in a moment here, when I clean that up, I'm going to have x plus 1. If you jump to that too, that's fine. I don't have a problem with that. But that's what's really going on, is I have minus a negative. And then I have y minus, and again, I actually have a negative 6, so it's y minus negative 6. In a moment, it'll be y plus 6 squared. And it's supposed to equal 1/3, because that's my radius, squared. So this is simply evaluating substituting the values into the formula. That's all I did. If you don't need that step to show the next step, that's okay. It's not crucial to do so, but minus a negative is plus. This is x plus 1 squared. And minus the negative over here is also addition, so it's y plus 6 squared. And then what is 1/3 squared? Close. 1/9. Yeah, so make sure you're squaring, not multiplying by 2. So we have 1 on top and 9 on bottom. So this would be the final version of what I get. The tricky thing about circles is that while you can do a lot of linear things in your calculator to confirm, you don't have a very good tool which to do it with your calculator for circles, at least not most calculators, because they make you enter things in a way that's a function. Okay, we haven't talked about functions yet, but circles fail the function test. So they become tricky to enter into your calculator to sort of confirm that you did things right. Okay, so our next examples are going to actually be to take an equation and to find the center and the radius, and then to graph them. Okay, I didn't ask you over here on this one to graph them. It'd be ugly because the radius is 1/3, to be honest. That would be a messy thing to graph. This one's not too bad, though. So looking at this right now, first we're going to identify the center and the radius. Now, our general equation, which I'll copy and paste over here, has the center showing up with these locations, right, h and k. So what do you notice about problem A? It's just the x that's squared and the y that's squared, right? You don't have something in parentheses with the x or with the y. So since you don't see anything there, what's there? Close. It's 0. Yeah, it's 0. So what you actually have happening here is you have x minus 0 squared and y minus 0 squared. That's what's going on. So my center here is actually the origin, which is always easier to draw, by the way. Love it when it's the origin. What's my radius? That is, what is being squared on the other side? It's 4. Okay, common mistake is to just go with 16. Don't forget, the 16 is not being squared. The 16 has already been squared and resulted in 16. So my radius is actually 4. So on my picture, I need to plot the center as a reference point. I did mine in green, it's this tiny little dot. And I'm going to count 4 in every direction because my radius is 4. And then I'm going to do my best to connect those dots. So I have a dot here, 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 here. Mine is definitely not to scale. At least on my screen it looks a little longer on the left-hand side. But we're going to do our best to connect this in a circle. We'll call that a circle by definition today. Okay, does that make sense? Okay, the next one is not going to have a center of 0, 0, so it's actually going to be a little bit more difficult to write. I would encourage you to take the equation, though, and to pretty much get it into the form that's up there in that black bar. Okay? In other words, move the x and the y over to the same side. It's a little easier to look at it and to think about that way. So this piece right here that's minus the y minus 3 squared, I don't need to multiply it out. I'm just going to add that whole chunk to the other side. So we will add y minus 3 squared, like that. So I have x squared plus y minus 3 squared equals 9. From this, it's a lot easier to just read things off. So from there, what is my center? 0, 3. Very good. 0, 3. Everybody good with that? Okay. Do remember that the sign's opposite. Okay. Why is the sign opposite? Because the equation has the subtraction signs as a part of them. So to be honest, whatever the sign is inside the parentheses with the y, like after the y, it's the opposite sign that actually becomes the location. So if this had actually said y plus 3, my center would actually have a negative 3 component, not a positive 3 component. Also another easy mistake to just overlook. How about my radius? Yeah, it's 3 because this is the same right here as 3 squared, right? So over on my picture, I'm going to count out to the center 0, 3. Remember, x is first, y is second. So x measures how far left and right I go. So I'm not going to go anywhere because it says 0. So I'm going to stay right there in the middle on the origin. And then the 3 on the y value says I'm going to go up 3. So my center is actually right here. And then my radius being 3 means I go out 3 in each direction. Now I'm just going to mark it on the axes, not because I'm using the axes to draw it, but just to measure visually what's happening. So here's, that's a little bit off. Okay, so here from my dot down 3 puts me back at the origin for one of my locations of my circle. From my center to the right 3 puts me over here. To the left 3 puts me over here. And then up 3 puts me right here. Okay, and then we're going to connect those dots as best we can in a circular fashion. That might be slightly better than the last one, I'm not sure. So we have our second circle. So any questions on that? Yep, Tori.
Can you re-explain why the y on the center is in the negative?
Yeah. So up here in the equation, there's a negative that's part of the equation.
Oh,
So the center here is HK, and it doesn't include the negatives that are part of the equation. So you might just write yourself a note to always remember that the signs are switched from what they actually show up in the formula.
So is there ever a time where it's going to be 1 plus? Like
Sure.
1 plus 3?
Absolutely. It's not my next example, but I don't even have one. How did I not get one as an example? But yes, it can.
But it's just
Evidently.
opposite. It's
Yeah, it would just be the opposite. So if it showed up as y plus 7, then negative 7 would be part of your center location, either the x or the y, depending on what it was grouped with. Yeah.
And I'm not sure if you've already answered this question. Are we going to get the formulas in the black? Or
No.
No, so we have to memorize them.
You have to memorize those. And remember, the distance formula and the center of the circle formula are actually really the same formula. Just letters are slightly different. But yes, so far now I've given you 3 formulas. So if you want to keep a running list of those so that you can kind of reference them multiple times so that when you get to the test, you've memorized them because you've looked at them so many times, that wouldn't be a bad idea. So just have a running list. We're not going to always have a ton of formulas in every lesson, but today we do have 3. Yeah. Okay, so B was really nice. Well, A was really nice because I don't have anything, grouped with the x and the y that are being squared. B was really nice because I had the grouping already present there. But if you take a look at the next problem, it's not very nice. And the reason that it's not very nice is because I have things that are not squared, but they're also not constants, right? So over here on this one number, the letter A one, I had the x squared and I had the y squared and I had a constant, and that's all I had. But over here on number 5, not only do I have the x squared and the y squared, I've also got this 8x and I've got this 10y business going on. And that makes things look really tricky. And in fact, it's much more difficult. So there's a process called completing the square. I know that all of you have done this before, but completing the square is often not anyone's favorite thing to do. So it might be one of those things you categorized in the, I hope I never have to do this again, and lo and behold, here we are. So here's the way completing the square works. Everything that has an x in it and everything that has a y in it gets grouped together like that first. Now, this isn't traditional factoring. I'm not taking x squared minus 8x and taking out an x. It's not what I'm doing. But I am grouping them together. So as I rewrite this, I'm going to leave a space after the 8x. And I'm even going to put an underlined spot to remind us that there's a space here. And I'm going to do the same thing after the 10y. I'm going to leave a space, and it equals the negative 5. So far so good. All I've done is just add these extra spots in here. So completing the square has a key, like a thing that you to remember. The important key to completing the square is to take the middle value, we call the middle value b, divide it by 2, and square it. So the middle value that I'm referencing are the values that are being multiplied and creating my problems, the 8 and the 10. Those are the b values. And you might even notice that I'm sort of being a little bit lazy and not saying negative 8 and negative 10. I can actually get away with that because when I square it right over there, the signs all become positive. So the squaring part is going to eliminate whether it's positive or negative. It's not going to matter. It's just going to be positive. So when I take this negative 8, I'll just write it to the side now just so that we see it. And I divide it by 2, and I square it. What is negative 8 divided by 2? Negative 4. And what is negative 4 squared? It is 16. That's what's going to go in that blank. Now, you cannot just go adding something to one side of the equation unless you also add it to the other side, right? An equation is a balance. I have now added 16, and my equation is like lopsided. So I have to add 16 to the other side to get it to balance over. So that 16 also has to be added to the right-hand side. And we're going to repeat the same process for my negative 10. So I have negative 10 divided by 2. So what is negative 10 divided by 2? Negative 5. And what is negative 5 squared? 25. So I'm going to put a 25, positive always, because I squared it, right, in the second blank. And again, now I've added 25 to the left-hand side of the equation. I need to add 25 to the right-hand side to get it to balance. So I need to add a 25 right here. Now, the purpose of why we've done this has yet to become clear. But are you okay with the fact that I didn't actually change anything? I just added something on the same side, or on the two sides of the equation, so it's still balanced. So why? Why in the world is this the appropriate value to add? Why did I want to do this? Aside from just making things longer, what purpose did it solve? Well, it solved the purpose of being able to take this and to put it into this form where I have x minus h or x plus h, depending on what the value is, right? Something squared. What happens right here is that this will now be a perfect square trinomial. And we didn't talk a whole lot about perfect square trinomials when we were in chapter P, but they always factor perfectly as two pieces that are identical. So I'm going to actually do the factoring out like we would do if it was factoring with guess and check, because I want you to see that it works. But then once we do that, you're actually able to do it the same way all the time. So we can actually take this now, and I can factor it. It'll factor as x and x. The signs have to be the same because it's positive 16 at the end, and they're negative because it's negative 8 in the middle, so they're the same and they're negative. And then I need two numbers that multiply to 16, add to 8. 4 and 4, right? Perfect squares. The same thing is going to happen over here with my y. There's an addition sign in between, but then I'm going to do my factoring. It's y and it's y. The signs are the same, and they're both negative because it's negative 10 in the middle. Two numbers that multiply to 25 add to 10. 5 and 5. The same. always happens. And it always happens because we did this. We chose that number on purpose to force that to happen. It's not an accidental thing. It's an on purpose. That's what I tell my kids when they tell me it was an accident. No, that was an on purpose. We did this on purpose, okay? Over here, then, I need to simplify whatever I have. So I have -5, positive 16, and positive 25. What is that? 36. Okay, so far so good? Okay, this is actually looking really close to the part that's up there in the black bar. It's really close. The only thing that's lacking is sort of the notation that instead of writing x minus 4 times x minus 4, I can write x minus 4 squared. And instead of y minus 5 times y minus 5, I can write y minus 5 squared. And just for the sake, because we can, so that we can identify it, what is the value on the right-hand side that's squared? It's a 6. So it's really 6 squared on the right. So at this point, if we were asked to, we aren't asked to on this particular one, but if we were asked to, could we identify the center and the radius? Yes, we could. Could we draw it? Yeah, we could. Okay? So I introduced this problem so that we can, in fact, do those things. But I want to make one more mention of how we don't really need to do this step. We can move straight from here to here. So I'd like to show you the pieces that show up when you do that, and we'll do that on the next one. You can always do it if you need to. So if you need to show that step, by all means, show it. But what really happens here when we do the factoring is this piece is the square root. So what's the square root of x? Or sorry, the square root of x squared? It's x. What's the square root of 16? It's 4. And I take the sign from what's in the middle. It's a negative. That's the pattern that always presents. Always. Because we did it on purpose. So let's actually do one on purpose where we continue and then find the center and the radius. This one's kind of ugly because it's got a fraction, okay? But we're not going to deal with the fraction too much except for the moment to throw it to the other side. Okay, I want the constant to be on the other side anyway, and then I can ignore it for the time being. So I'm going to group my x's, I'm going to group my y's, and I'm going to move this to the other side. So I'm going to have my x squared minus 3x, and I'm going to leave a blank. I'm going to have my y squared plus 2y, and I'm going to leave a blank. And then I move the negative 3/4 to the other side by adding, so it's positive 3/4. Now remember, your key is to take b divided by 2 and square it. So our first b value is -3. So I need -3 divided by 2 and squared, which is not a nice value, by the way. That's okay. -3 and 2 don't actually divide, right? So we end up just squaring it. So always we get a positive, but that would give me 3 squared on top, which gives me 9, and 2 squared on bottom, which gives me 4. So in that first blank, as unattractive as that might be, I do have the fraction 9/4. But that's actually not the worst thing in the world on the other side, because I already had something over 4. Now I've got 9/4 to add to my 3/4, right? It balances. Okay, let's do it again for the second value. It's a little nicer. It's the number 2, right? So my second b value is 2. 2 divided by 2 squared. What is that? That's 1. I like that one better. So we've got a 1 here, and to balance, we have a 1 here. Okay, so if I actually gave you like this thing and told you to factor it, let me just tell you, first of all, that would be mean. Because it's got a fraction in it, right? It would be mean for me to tell you to actually just factor this without knowing where it came from. But it actually came from us doing this on purpose. On purpose, we created 9/4. So just like I showed you over here, where I can take the square root of the first term and I can take the square root of the last term, and I can use the middle value, I can use that to factor this easy. This will factor as the x first, as 3/2, because that's what the square root of 9 over the square root of 4 is. Square root of 9 is 3, square root of 4 is 2. And then I get the sign from the middle. And this is squared. It's easy to factor because it's purposely chosen to do that. Same is true for the second one, although it would not be hard to factor anyway. Right? The y squared gives me a y. The 1 square rooted gives me a 1. And the sign in the middle, oh, it is a positive. I did have a positive in there just for you, Kylie. There's a positive. I didn't see it when I was looking before. Okay, is that all right? Let's see what we've got on the right-hand side. What is 3/4 plus 9/4?
3.
Yeah, it's 12/4, which is 3. You're exactly right. So this is 3, plus my 1 is 4. I have 4 on the right-hand side. That's lovely. Because 4 is the same thing as what squared?
2.
It's 2 squared. Okay? You don't have to write the 2 squared, but I just want you to see it to remind you. So we're going to find, or write now, the center and the radius. What is the center? Good. It's 3/2, and then it's a -1, right? It's the opposite sign of the positive one. And what's my radius? It's 2. You got it. So even with the fractions being involved, because they came about in a certain way, they're not all that bad.
Are the fraction problems always worked out pretty nice up there?
You know, I find in general that when books create problems, they do that a lot of the times. So if it didn't happen, it would be few and far between. Yeah. Okay, a little bit of a change in direction. We're going to talk a little bit about lines. So to start with, we're going to talk about the standard form of a line. We're not going to get too far into lines today. It's just a little bit of lines in this section. The standard form of a line is ax plus by equals c. Like, we never see them really written that way for the purpose of like graphing or anything like that. Sometimes we see them written that way, and we will in chapter 5 when we're looking at solving like multiple equations at the same time. We call them systems of equations. A and B and C have a few features. The A and the B are not both 0. That's an important feature. Another thing here is that the A and the B and the C are integers, right? So no fractions if it's in standard form. And the A value is greater than 0. Starts out positive. So those are some details that are making it a standard form. So number 7's standard form. It's standard form because I have all coefficients that are integers, 5, -2, and 10. Those are integers. The 5 at the beginning is positive. That's the x value, right? The x coefficient. And I have it in that sort of standard order, right? The x comes, and then the y comes, and on the other side's the constant. So it is in standard form. What we're looking at in this section is using x and y intercepts for graphing. So we don't often think to do that, but some equations do not solve nicely for y equals to be able to do the graphing. They just don't. So we're going to look at another way of doing graphing, which is x and y intercepts. So an x-intercept means it's where it crosses the x-axis, right? That's what it means to have an x-intercept. It crosses the x-axis. And this happens when y equals 0. That's what an x-intercept is. It's when y equals 0. So if we take our equation and we let y equal to 0, we can find out what the x-intercept is, at least the x value of it initially. So the 2 times 0, of course, is 0. So I have 5x equals 10. And if I divide by 5, what's x?
2.
X is 2. Now, it is important to realize that an x and a y-intercept are an ordered pair. So this is x equals 2 and y equals 0. That's the x-intercept, not just 2. Okay, if you tell me x-intercept is 2, you've missed a little bit of the detail. We're going to do the same thing for the y-intercept before we go to graphing it. So if the x-intercept is when y equals 0, then the y-intercept means that x equals 0. So I have 5 times 0 minus 2y equals 10. So negative 2y equals 10. Divide by negative 2. What is the y value? It's negative 5. So again, the ordered pair then is x equals 0 y equal -5. So this gives me 2 points, and we're going to put them onto the graph. So the first one is 2, 0. So 2, 0 would be about right there. The second one is 0, -5. So that would be about right here. And then we're going to connect the dots. So we connect them, something like that, with arrows on the end. So far, so good. This one was really nice. I could hash mark things out in a way that was lovely. I wanted to show you what happens when the values end up being not so nice to sort of hash mark them out lovely. Hopefully, even by looking at this, you're like, ooh. I guess maybe that's not hopefully, but you should be looking at this and going, ew. There's fractions, and I've got 600 on the other side. So let's see what happens as we look at x and y intercepts. Now, this is not in standard form, right? So what is wrong with this being in standard form? How does it fail? They're not all integers, right? I wrote a detail at the top that says a, b, and c need to be integers, and a and b are fractions. So this is not in standard form. But it is like the x and then the y and then the constant. So it has that feature the same. I don't need it in standard form to be able to use the x-intercepts and the y-intercepts. I just thought I would mention that it's not actually standard form as it's written. So the x-intercepts means y equals 0. So I have 1/2 x plus 1/3 times 0 equals 600. So this is just 1/2 x equals 600. How do I get rid of the 1/2? Multiply by 2, right. So I'm going to multiply both sides by 2. So my x value gives me a 1200. Yeah. So my x-intercept is 1200, 0. I'm not going to hash out 1200 on my axes. I promise. I'll show you in a minute. Let's do the y-intercept. The y-intercept, which means that x is equal to 0, is 1/2 times 0 plus 1/3 times y equals 600. So this is 1/3 y equals 600. How do I eliminate the 1/3 y? Yeah, I'm going to multiply by 3. So what's y going to equal? 1800. So this is x equals 0, y equals 1800. Those are my two intercepts. So what do I do? Because I'm definitely not going to mark those out this way, right? So I'm going to put these on the graph. This one here, the 1200, 0, I need to be on this side anyway, right? The right-hand side. So I'm going to come out here, and I'm going to put in here, wherever I want to put it, 1200. And I'm just going to mark it and say it's 1200. Literally what I'm going to do. I'm just going to say this is 1200. I'm going to put it there. And I'm going to put a dot. The other one says that my y value is 1800, so that would also be up on the y-axis on the top. And I'm going to do the same thing. And I'm going to mark it. I'm going to say that it's 1800. Okay, you have to write them in when you're not using hash marks. Otherwise, I wouldn't necessarily know that. And then you're going to connect the dots just like before. Okay, hang on. I'm going to fix that. There we go. Arrows on the end. And that would be my graph. One other thing today, last thing. The last thing we're going to take a look at is what happens when we have horizontal and vertical lines. So many, many years ago, I had somebody show me a really cool acronym that I'm going to pass along to you. And the acronym is called hoyvox. Hoyvux. Hoyvox. Has anybody seen hoyvox before? Yeah, I think it was just like this one person that knew it from one teacher somewhere along the way. I don't even know, but it was cool. So I'm going to show you this cool thing. H stands for horizontal. The O stands for the number 0. 0 slope, and the y stands for the equation y equals. V stands for vertical. The u stands for undefined slope. And the x is for the equation x equals. Hoyvox. So what it does is it tells you how to deal with horizontal versus vertical lines and how they're different in terms of their slopes and their equations. So we're going to graph two lines. And I'm going to do it from this perspective, and then I'm also going to do it from a different perspective too, just in case you're more of a visual person instead of mnemonic device kind of thing. So this one right here, x equals -3. According to what I just saw on the other side, my other slide, excuse me, because this is x equals, the part that's circled in yellow, I actually have a what kind of line? A vertical line. This is a vertical line. And according to what I saw on the other slide, when I have a y equals, what kind of a line do I have? It is horizontal. So if I'm looking at my x equals -3, well, x is -3 if I move left 3. And I need a value that is left 3, and it goes through that point, and it's vertical. So the vertical line that I would be drawing, hang on, would look like this. That's the vertical line, x equals -3. The other one said y equals 2. So for y equals to 2, I would go up 2 on the y-axis, and there's my dot. And it says that it's supposed to be a horizontal line. So my horizontal line would look like, it's going to overlap, but look like that. Arrows on the end. That horizontal line is the equation y equal to. Okay, so that's how you can think about it if you'd like from this perspective. If you were asked questions about this, here's my line. It's x equal -3. What's its slope? Well, its slope's undefined. Vertical lines have undefined slope. If you were looking over here at the y equals 2 and you were asked what is its slope, if you were thinking from this mnemonic device, yeah, I was in the right spot. You've got a horizontal line, so its slope is 0. Okay? We never say that a slope does not exist, because sometimes when people say does not exist, they mean 0, and sometimes when they say does not exist, they mean undefined. It's an ambiguous kind of a description. It's either 0 or it's undefined. But let me mention one other thing, and then we'll be done for today. If you're a visual person, instead of thinking from my acronym perspective, this yellow line that's vertical that I've got drawn on here, what is the x value at every location along that line? It is -3. It doesn't matter if I am down here. I wanted it to be quiet. Hang on. Or if I'm on the axis, or if I'm up here, or if I continue to keep, you have to keep drawing it. No matter where I am, that x value is always -3. So it should be a real quick check for you. Did I draw it right? Is the x value -3 everywhere on that line? And it is, then you've drawn it correctly. Same thing for my y equals. The y value everywhere along this line is always y equal to 2, because I'm 2 units above the axis, right? I'm elevated 2 units. So the y value is always x equal to 2. So if you think more visually, you can also go from that perspective. Any questions? Alrighty, that'll be it for today.